So here in this part, we're going to talk about how to visually see when two functions are inverse to each other graphically. Now, what you see in the front are these x and y values from the handout that you receive in class, and then we talked about how to flip, or that when you flip the x and y values, that you're going to see that these functions are indeed inverse to each other. So the first table, f of x, with this, and then the second function, f to the negative 1 of x, which is the symbol for inverse function. So these two functions are indeed inverse to each other. As you closely examine the x and y values between each relation, between each xy table, you will see that they are indeed the flipped version of each other. So again, look at the first coordinate point of f of x, which is negative 2, 9. When you flip the x and y values for f to the negative 1 of x, you should have 9, negative 2. And if you look at the second coordinate point for f of x, which is negative 6, 6, when you flip it, then for f of negative 1 of x, you should have 6 to negative 6. So if you were to examine each x, y values, then they are, each of them, flipped version of each other. So we know that these functions are inverse to each other. And you will see how two graph functions are inverse to each other when you're looking on an xy plane. So I want to graph the first function in blue, f of x. So starting with my first coordinate point, negative 2, 9, which is right here, and then moving on to my second, which is negative 6, 6. Negative 6, 6 here. Moving to my third point from my second point, negative 6, 3. Then continuing to my fourth point, negative 2, 4. Moving to my fifth point, 2, 3. To my sixth point, 2, 6. And then it will go back to the point where we started, which is negative 2, 9. So here's the graph for the function f of x. Now let's take a look when we're graphing f to the negative 1 of x. I'm going to start at 9, negative 2, which is over here. Then move into my second point, 6, negative 6. Then moving towards 3, negative 6. For my fourth point, 4, negative 2. To my fifth point, 3, negative 2. Well, 3, sorry, 3, positive 2. Then it will be 6, 2. Then from there, I'm going back to where I started. So 9, negative 2. So at first, you think that the function is rotated. But if I were to add in this diagonal line, this diagonal line is represented by y equal to x. That's the equation for the diagonal line. So if you closely examine these two graph functions in terms of the dotted line, if you were to say fold the xy plane on the dotted line, then you will see that these two functions will overlap each other. So in respect to the dotted line, you can say that these two graphs are flipped version of each other, or in terms of what we did in transformation, reflection to each other. So you can say that the blue function, the blue graph, is reflecting across y equals x. Or you can say that the blue graph is the flipped version, flipped over y equals x to match with the red graph. So If you were to check graphically that these two functions are inverse to each other, simply see if they are the flipped version of each other across y equals x, meaning across the dotted line as you can see here. That means that each part, every part of it and each of them has to line up or overlap each other if you were to photograph over or across the dotted line. Or if you were to match the x and y table, the relationship of their corner points, again, each corner point are a flipped version of each other, therefore the graphs are a flipped version of each other. So this is how you would determine graphically if two functions are inverse to each other. In this example, you can see that these graphs are indeed inverse to each other.